All right, let's just jump right into it. We're all using these incredibly powerful AI models every day, right? But have you ever stopped and wondered why, for all that brain power, do they sometimes feel, well, kind of slow? Today, we're going to unpack the really clever engineering that makes AI not just smart, but feel instantaneous. This is the story of the Inference Optimizer.
It's a weird paradox, isn't it? You've got models with billions, even trillions of parameters. They can write poetry, they can write code, but then you ask a simple question, and there's that noticeable, frustrating pause. Well, this exact problem was driving an engineer named Timothy absolutely crazy. And it's his frustration that really sets the stage for a major breakthrough.
This quote just perfectly nails what Timothy was feeling. He looked at his system and realized they were using their biggest, most powerful, most expensive AI model for every single query. So asking something simple like, hey, is the archive open today, was kicking off the same massive computational effort as asking it to solve a complex research problem. It wasn't just slow and inefficient, it was costing them a fortune.
Now, his colleague, Margaret, she actually had a name for this problem, the density trap. And it's the perfect way to describe it, right? It's this idea of being trapped, using your biggest, heaviest tool for every single job, no matter how small. And you know, the first step to solving any problem is giving it a name. Now, they had a clear target.
So how do you escape the density trap? Well, Margaret had a plan, and the very first part of her solution was to deploy something she called a scout. This was a whole new way of thinking about AI architecture, technically known as tiered inference. Of course, this brings up a pretty obvious and important question. If you're not going to use the giant model for everything, how do you decide what goes where? You need some kind of intelligent traffic cop, a smart front door for all the questions coming in.
Margaret's idea was brilliantly simple. She said, we have to stop using a giant cargo plane for every single delivery. Instead, the new way deploys a scout. Now, this scout is a small language model, an SLM, and it acts like a sleek little jet. It's built for speed, for agility, not for heavy lifting.
And the impact? It's just staggering. This little scout model handles what Margaret called the daily chatter, the huge volume of simple, routine questions. It turns out it can successfully field about 80% of all queries, instantly. Only the truly complex 20% ever get escalated to the bigger, slower models. So how does it decide what's simple and what's complex? The system, the official term is tiered inference, uses what's called a confidence threshold. The Scout model makes a split-second judgment. If it's, say, 95% sure it knows the right answer, bam, it responds immediately. But if its confidence drops below that line, it knows, hey, this one's not for me, and it passes the request up the chain. It's a totally brilliant and incredibly efficient sorting system. Okay, so the Scout is handling all the simple stuff, which is awesome. But what about that 20%, the complex tasks that still need that big, slow model? Well, Margaret had a plan for that too. It was time to engage the turbo. And this was exactly Timothy's concern. I mean, fixing 80% of the problem is fantastic, but that last 20% still represents a major bottleneck. The experience for users asking those deep, complex questions was still too slow. The sledgehammer still took way too long to swing. The solution is this amazing technique called speculative decoding, and yeah, it is just as cool as it sounds. The basic idea is, instead of making the big model do all the heavy lifting from scratch, you use a small, fast model to guess or speculate what the answer is probably going to be. It creates a first draft. Think of it like this. You have a really fast typist and a genius editor working together. The fast typist, that's our small model, just flies, typing out a few sentences at incredible speed. Then, the genius editor, our large model, doesn't retype it. It just glances over the whole chunk of text and either says, yep, that's good, or makes a quick correction, all in one go. It's this beautiful parallel process that uses the strengths of both models. And the result of this? A massive performance boost. By having the small model draft the answer and the large model just validate it, the whole system becomes 3 times faster for those really complex queries. You get the genius-level intelligence, but at the speed of the fast typist. It's the best of both worlds. So, we've got a Scout for the simple tasks and a Turbo for the complex ones. What else could there possibly be? Well, the final piece of this puzzle deals with a problem every system has: people asking the same things over and over again. This is where the smart cache comes in. Timothy's final question really gets to the core of what ultimate efficiency looks like. Why should a super smart system have to rethink the same problem from scratch every time it's asked? Shouldn't it be able to learn and, remember?
And this is where semantic caching comes in. And honestly, this is way more clever than just a simple copy and paste from your history. Instead of storing the text of an answer, it stores the meaning. It actually saves the intermediate mathematical state, the thought process, if you will, of the model. So if a new question comes in that's worded a bit differently but is semantically identical, the system can just reuse that previous thought instead of starting all over again.
This leads us to this really powerful insight from Margaret. The ultimate goal isn't just about accelerating the computation, it's about avoiding it completely whenever you can. True efficiency is about not having to do the same work again. It's about thinking less, but still getting the same or even better results.
So, what happens when you finally put all three of these amazing solutions together? You've got the Scout, the Turbo, and the Smart Cache all working in concert. Well, you get the resolution. You get the complete inference optimizer in action.
For Timothy, the change was like night and day. His stopwatch, which used to be this symbol of his frustration, just stayed in his pocket. User queries, from the simplest little questions to the most complex ones, were answered with this fluidity that just felt instantaneous. The system wasn't just intelligent anymore, it was truly responsive.
So let's just do a quick recap of this incredible team. First up, you've got the Scout, using tiered inference to filter out and handle 80% of the easy stuff. Then for the hard stuff, the Turbo kicks in, using speculative decoding to make those jobs 3 times faster. And finally, the Smart Cache is always there in the background, using semantic caching to remember thoughts and get rid of repetitive work. Together, they form a truly optimized system.
And all of this brings us to a final and I think crucial point from Margaret. As we build these ever more powerful AI, the ultimate goal isn't just making them smarter. It's about respecting our time. The true measure of any advanced technology is really how seamlessly and how quickly it helps us. Because in a world of infinite data, the most valuable, the most scarce resource we have, it isn't intelligence, it's time.